Welcome to our course on the challenges of today's Agriculture 4.0, where we explore the complexities and hurdles faced in this era of digital farming. In this session, we will delve into the key obstacles that farmers, innovators, and policymakers encounter as they strive to harness the full potential of technological advancements in agriculture. To address today's agricultural challenges, technology offers a wide range of possibilities to ensure the food security of countries in the future. Agriculture 4.0 cannot provide the definitive solution. However, the Agriculture 4.0 paradigm has characteristics that can help mitigate the effects and bring home the lesson that the pandemic should have already taught us to speed up the transition. In fact, the Agriculture 4.0 market is growing at a significant rate. In the space of 3 years, we have gone from a turnover of scarce 100 million to 1.5 billion euros. Furthermore, there are more than 1,000 agricultural solutions on the market, and thousands of companies have already adopted at least one 4.0 technology. The food crisis, triggered by the wheat war, is the ghost that nowadays lurks in the Mediterranean and the world after the UN warned that the nightmare of food shortage could materialize. We have discovered how fragile the world is during the pandemic and the lockdown, when supply chains have been disrupted. We have experienced firsthand the upheavals during the last torrid seasons due to climate change. The food system, made fragile by the pandemic, is therefore in danger of coming out with broken bones due to the energy shock, the drought caused by climate change, and now the war. The price of cereals has risen globally by 53% since the beginning of the war, triggering, among other things, an inflation that has not been seen for decades in the West, where we lived pre-pandemic in the so-called deflationist century. But the price of wheat rose by a further 6% last May 16th, when India, due to a heat wave, announced that it would block exports, for fear that famine will hit the country, just as an example amongst other cases around the world. Extreme poverty could therefore quadruple, while people who did not have basic food, and enough food to live, could reach 250 million, and therefore could die of hunger. Meanwhile, in this scenario of war and political and social uncertainty, the price of wheat rises, cannibalizing profit margins, due to the increase in the prices of fertilizers and energy. The main costs that weigh on farmers' budgets are rising sharply due to sanctions. Without fertilizer, field productivity could also collapse vertically. Global yield could drop to its lowest ever levels. In fact, a fifth of fertilizer exports are restricted, and this will cause a devastating impact on the food crisis. World hunger can only increase. Another important issue is that of the discontinuity of supply chains, due to the war on wheat, triggered by the conflict. In the livestock sector, companies are struggling to receive feed and grain from the usual suppliers, perhaps involved in the conflict. Companies are forced to suddenly change suppliers, without being able to carry out a preventive assessment of the quality of the feed or grain purchased. It happens that customers are buying blindfolded. The verification of the quality, traceability, and transparency of where and how the goods were harvested and produced takes place only after the purchase has been made. Producing more became a necessity as the human population is growing, and we must meet people's food needs in a scenario of strong population growth globally. Furthermore, producing more with fewer resources increases the level of independence regarding supplies coming from abroad, and in case of resource scarcity given by climate change and poor management of available resources, not in the short, but in the medium-long term. If companies invest in these tools, Agriculture 4.0 represents a paradigm for increasing independence from the supply chain on which it is said that we can no longer count. Precision agriculture, aka Agriculture 4.0, is a management strategy that gathers, processes, and analyses temporal, spatial, and individual data and combines it with other information to support management decisions according to estimated variability for improved resource use efficiency, productivity, quality, profitability, and sustainability of agricultural production. Precision farming can potentially help farmers produce higher yields, less crop damage, and fewer inputs, such as water, fuel, and fertilizer. The European Joint Research Centre estimates that precision agriculture and farming can make a huge carbon dioxide saving contribution in European agriculture until 2030. Using fewer inputs means reducing the purchase of products that are in short supply or whose costs have greatly increased, further reducing the margins that companies generally use to invest and trigger the driving force to increase the level of digitization of agricultural production processes. Furthermore, the smart parallel drive tractors allow you to work the same field surface using less diesel because the parallel drive avoids going over the same spot several times. On large surfaces, it significantly reduces fuel consumption. As mentioned before, agriculture is squarely in the midst of the fourth industrial revolution. Emergent, game-changing technologies are driving economic, environmental, and social change in the global food system. And in the face of rising hunger populations and a changing climate, everyone from policymakers to billionaires is paying attention. The U.S. Association of Equipment Manufacturers published a study in February 2022 investigating how new technologies might help farmers do more with less. On average, new technology trailers achieved a 4% increase in crop production, 7% reduction in fertilizer use, 9% reduction in herbicide use, 6% reduction in fossil fuel use, and 4% reduction in water use. Another valuable technology in the current scenario concerns IoT sensors to assess the level of grain stocks in major warehouses to answer a crucial question: how long can I tolerate shortages of grain based on the stocks I actually have in the silos? Digital can answer this question. Thanks to Internet of Things, sensors in silos that would be able to monitor the level of stocks in real time. Key Internet of Things, or IoT, is a system of interrelated computing devices, mechanical and digital machines, objects, animals, or people that are provided with unique identifiers and the ability to transfer data over a network without requiring human-to-human or human-to-computer interaction. A thing on the Internet of Things can be a person with a heart monitor implant, a farm animal with a biochip transponder, an automobile that has built-in sensors to alert the driver when tire pressure is low, or any other natural or man-made object that can be assigned an Internet Protocol address and is able to transfer data over a network. An IoT ecosystem consists of web-enabled smart devices that use embedded systems, such as processors, sensors, and communication hardware to collect, send, and act on data they acquire from their environments. IoT devices share the sensor data they collect by connecting to an IoT gateway or other edge device, where data is either sent to the cloud to be analyzed or analyzed locally. Sometimes, these devices communicate with other related devices and act on the information they get from one another. The devices do most of the work without human intervention, although people can interact with the device, for instance, to set them up, give them instructions, or access the data. Commercial tools and services for smart farming that make extensive use of machine learning are currently available to farmers, but most of them are focused on traditional ML techniques. A comparison of ML algorithms for predicting the yield of soybean crops is presented. The possibility of using different ML techniques in agriculture are discussed, but most of the present work is about statistical forecasting methods from weather data for predicting wheat yield. Since the mentioned surveys do not simultaneously cover forecasting, detection, and classification of diseases and pests, and do not fully explore recent deep learning-based techniques, the review performed in this paper aims to fill the gaps on these subjects. The literature review presented in this module aims to provide an early guidance on the development of such ML-based tools in order to provide farmers with data-driven decision-making assistance systems. In this way, farmers can be assisted with lowering the need for pesticide application and the harm that comes with it, while also preserving and enhancing crop quality and yield. This contributes to the continued availability of food to meet global population demands, while doing less damage to the planet. The application of ML-based techniques has promoted the emergence of projects that have enriched the development and the evolution of smart farming. Data gathering, data pre-processing, and ML classification models are the three basic steps of ML applications. Real-time monitoring is crucial. In fact, Europe must not only feed its population, but it is also an exporter of goods, so it also buys crops to process them and export. Our agro-food chain is put to the test. Instead, no one knew what the level of the silos was at the outbreak of the conflict due to the absence of IoT sensors where they would be needed. We have not yet learned the lesson of the pandemic. We hope that this tragic conflict will leave us as a positive legacy the need to monitor the real situation with IoT sensors. Farmers are applying Internet of Things technology to track crops remotely, using sensors to detect weed growth, water levels, and pest invasion. And we're not only seeing this on traditional farmlands. FARM66, located inside a Hong Kong skyscraper, is using IoT to help manage a 2,000 square meter indoor farm. The IoT-enabled agricultural industry is estimated to reach US $4.5 billion by 2025. In China, drones are being used to survey 20 million hectares of cotton, providing insights into pest protection, fertilizer and herbicide application, irrigation, and harvest timing to drive productivity. The history of agricultural modernization strongly suggests that increased productivity carries potential risks, including intensifying social inequality and ecological degradation. Either way, a pursuit of high-tech farming futures will lead to a unique set of both positive and negative consequences. Challenges include rising digital inequality, access to energy and other resources, varying laws and regulations, data interoperability, and security concerns. Smart farms are hackable farms. And with big corporations collecting and selling data from farmers, escalating tensions over data misuse is a considerable threat. Agriculture globally faces a perfect storm of a rapidly growing population demanding more kilojoules per day amid considerable environmental challenges, whilst needing to maintain livelihoods on 570 million farms worldwide, the bulk of them family enterprises. If integrated correctly, new technologies can enhance crop yields, reduce production costs, improve the traceability of food, eliminate unnecessary waste, and detect diseases in advance. But harnessing agriculture 4.0 seconds full value won't be easy. Industry, research, government, and commercial groups must work together to remove legal barriers, improve digital literacy and access, and enable platforms to better exchange secure data. Agriculture may have been some of humans' earliest technological steps, but it will take the full suite of human ingenuity to ensure they continue. Thank you for joining us as we explored the challenges of today's agriculture and how Agriculture 4.0 offers solutions. By harnessing technology, data-driven insights, and sustainable practices, we can overcome these obstacles and pave the way for a more efficient, resilient, and environmentally friendly agricultural sector. Let's embrace the opportunities that Agriculture 4.0 presents and work together to shape a better future for farming. And remember, teamwork makes the dream work.